Hello friends, now we are studying overcurrent protection. So before understanding the concept of overcurrent protection, let us understand the basic details of overcurrent protection. So in overcurrent protection, we will use balance beam relay. So this is the combination of balance beam relay in which in one coil the operating torque will be provided, in one coil restraining torque will be provided. So we know that this operating current has been the secondary current and this restraining coil has the secondary of potential transformer. So we know that the torque in this operating coil will be actuated by this current and the torque in this restraining coil is actuated by this voltage. So correspondingly we can write that T1 value is equal to KAI square and the restraining coil we can say T2 is equal to KBV square. So now we know that in case of CT ratio, the capital I upon small I will be equal to constant. Let us assume K dash, K dash. So we can write from here the value of small I is equal to capital I upon K dash. And in the same way for potential transformer, capital V upon small v used to be equal to K double dash. So from here we can write small v is equal to V upon K double dash, putting this value here in operating coil. You know, you have seen this example when we discuss this coordination diagram. So this is all the concept, or you can see for the potential transformer in relay. So this is plus, this is minus, this is plus, this is minus, this is capital B, this is small v, this is capital I, this is small I. So this is how the configuration will be. So putting all this value T1 we will be getting Ka into I square means capital I upon small k dash square. So T1 when we will take this constant, so K1 I square. So this is the operating torque, and in restraining coil we can put the value of V upon K double dash square. So this when we can write T2 is equal to we can write K2V square. So this is operating torque, this is operating torque, and this is restraining torque. The relay used to be generally in wedge off condition, means let us assume this has been applied the 5 Newton and the same is applied outward to this operating cut start by this restraining relay. So this 5 Newton is restraining torque and here we know the hinge is present. So now what we'll be seeing, if the operating torque is greater than restraining torque, then this circuit breaker will be differentiated. But we have to check that during wedge off condition these forces are equal and this contact of circuit breaker will be closed. Then what will happen when the circuit breaker will be open or the relay will operate? Now we are going to see in detail. So relay will operate when relay will operate when T1 greater than T2. T1 greater than T2 means operating torque should be greater than restraining torque. So operating torque is nothing but K1 I square and greater than K2 V square. So here we can get V by I must be less than under root of K1 upon K2. So if you will see this V by I is Z, because we know that V by I ratio is Z, and if you are comparing with any quantity, so under root K1 upon K2 is also an impedance and we can write with the help of Z set, and we can write this V upon I Z seen. I will discuss the concept of Z seen with the numerical. So the relay will operate when Z seen is less than Z set. So if you will see guys in detail, this Z is the Z seen and here it has been written ZR. In the circuit it has been written like, I'm only replacing this. In the question it has been asked like this, and this has been written as ZR. This is written as ZR, and the same that will be replaced. So the question has been asked, the relay will operate when Z is less than ZR. Second option is Z is greater than ZR. Third option is Z should be greater than Z plus V upon small v. Fourth option is Z should be less than ZR plus capital I upon small I. So we have to choose one option from these given four options. So you will see carefully because this question has been asked in ES examination. So the first will be correct because Z seen Z should be less than ZR. So ZR means the replica impedance. Z seen is nothing but this is ZR. This is called as also replica impedance. Replica impedance. So guys, this is the actual circuit representation. See, the CT of secondary is coming to the operating coil and the secondary of potential transformer PT has been coming to restraining torque. So this is OC and this is REC. This is operating coil and this is restraining coil. So what is happening exactly if this is relay, then if we fault occurs, basically what happened, the voltage of here will reduce. So the voltage of here, that is this point relay, so the voltage will be reduced and the current value is increased. So this relay will C Z is equal to V upon I, that will be felt here, that will be calculated here, V upon I. So V value has been reduced and I value has been increased. So Z seen will be very less during fault. Z seen will be very less during fault and Z set is fixed value. So at Kirchhoff condition, Z seen is equal to Z set basically. Let us assume value 10 ohm and Z seen was also 10 ohm and that was at Kirchhoff condition. So now what happened when the fault occurs, this Z seen minimizes, means this becomes 4 ohm or 5 ohm. So this is the condition that relay will operate when Z seen will be less than Z set. So Z set is 10 and Z seen is 4 or 5. So this time relay will operate. So here it is all about the brief information of distance protection. Now in the next lecture we are going to cover the types of distance protection. Thank you.